Okay. Welcome everyone for a new seminar of the GloBIAS seminar series. Today we have Beth Cimini, Director for Bioimage Analysis at the Broad Institute, and Nodar Gogoberidze, Principal Software Engineer at the Broad Institute, to talk about CellProfiler, lessons from the first 20 years and plans for a few more than that. Just a few words about GloBIAS. We are the Global Bioimage Analyst Society. We have more than 50 volunteers, 12 members of the steering committee, which are coordinated by an amazing community manager, Krista Walter. We are a registered nonprofit association for bioimage analysts, and membership will be opened for you tomorrow. We want to create a sustainable base and legal entity to exchange knowledge between members, develop a curriculum for bioimage analysts, create and maintain repositories for training materials, and consolidate standards for bioimage analysis. We also organize and run in-person and online events, and we are kindly supported by the Chan Zuckerberg Initiative and hosted by German Bioimaging. Now, this seminar series is to provide a dynamic platform for bioimage analysts, and we want to enable community to stay up to date with the latest development in the field of bioimage analysis. We look at intermediate and advanced analysts as an audience and want to focus on practical and high-level content that extend beyond basic instruction. We thank the Broad Institute for providing the help with the infrastructure, and this seminar will be recorded. So your question will be later answered on the forum image.se. Before giving the stage to the speakers, we just announced that the next webinar will be about Fiji with Python power, the best of both worlds, and will be held by Curtis Rudin, Research Software Engineer at Laboratory for Optical and Computational Instrumentation, Madison University of Wisconsin. And this will be on Wednesday, 28 May 2025. Now, I thank again the speaker, Beth Cimini and Nodar Gogoberidze. The stage is yours.
Helps when I unmute. It goes so much better when I unmute. Well, thank you folks so much for having me. I am Beth Cimini. I am Associate Director of Bioimage Analysis here at the Broad. And I am joined by...
Hi, I'm Nodar. I'm Principal Software Engineer working in Beth's lab.
So we're going to talk to you a little bit today about CellProfiler. I'm excited for this because it's a different talk than the chance I usually get to get in terms about some of the technical details of CellProfiler, some of the things that we've learned from the first 20 years, though neither Nodar or I have been here for the entire sort of 20 plus years of CellProfiler's history, and then talk about what are some plans we have to make things better and what have we learned, what is different about supporting widely used open source legacy software that is maybe a little bit different than other things that we have done or that you might do. And please use the Q&A box. Folks there will be doing letting us know if there's anything that's sort of urgent to interrupt us right away. Otherwise, we'll be answering your questions at the end. I want to start actually with the acknowledgement slide, and that is just because at the end we're going to demo some new CellProfiler functionality that you will see in CellProfiler 5, and so I want to not forget to come back to the acknowledgements. What I'm going to show is a sort of fantastic amount of work from really great people, and including our sister lab now, the Carpenter Sing Lab, and Carpenter, one of the original creators of CellProfiler. And we're really grateful for all of the organizations and societies that make what we do possible. So we're going to start with that first. So starting just with a little bit of an introduction to CellProfiler. Hopefully you are at least vaguely familiar with what CellProfiler is and does, but for those of you who are a little bit out of date or just sort of haven't thought about CellProfiler in a while, CellProfiler, the reason that it came into existence is what if we wanted to do image analysis but at scale? What if we want to do image analysis reproducibly across many, many things, but we do not want to have to learn to code? Which means the magic part of CellProfiler is here. It's what we call the pipeline panel. And CellProfiler allows you to put together modules, and I'll tell you a little bit more about what we might have for modules and what kind, and like how many, and how it sort of makes up our code base a little bit later. But you can string modules together in a linear fashion, and only a linear fashion, and allows you to make, in theory, infinitely long, infinitely complex workflows that then can be applied to however many images you have, whether that is 5 images or 5 million images. Each module with each step within the workflow is configurable. The thing we think is the most important button in CellProfiler is this button right here. This is the help button. I'm going to talk a little bit more about documentation in a bit, but we really think of documentation as a major reason why CellProfiler is successful. CellProfiler is a really complex tool. The joke about flexible, powerful, easy to use, pick two, unfortunately applies to CellProfiler. But in order to make sure that with all the functionality we have, you never get lost, there's a help button beside each and every module and each and every setting in all of CellProfiler. You can start CellProfiler in either of two modes. Most people will start it in what's called test mode, where you can go in and interactively work with one image at a time and take a look at settings and things like that. And then once you've done that, you can set your output folder and start an analysis run that will multi-thread on your computer. If you're running in the GUI, you can also run CellProfiler headlessly. And that's the basic idea. I said I'd come back to modules, and so here I did. I had run these a few years ago, and the stats haven't changed too much. So CellProfiler currently has 95 modules, not counting plugins. And of the code that's in there, about 30% are comments or doc strings. So when I say CellProfiler, we have a big commitment to documentation. We have a big commitment to documentation. That's especially true within the modules, which tend to have the documentation all mixed in with all the different functionalities of things you might do, like image pre-processing or exporting a file. It's not necessarily good that those are all in the same place, but it's good that we have all that information. And overall, even when you count all of the sort of larger parts of the CellProfiler code base that a user will never touch, we try to have things be pretty well commented and documented. So overall, 20% of the code base is our CellProfiler manual or various comments or doc strings. So we take our commitment to having well-documented code very seriously. And there's across those 95 modules, this is, I haven't counted in a while. These are my numbers from 2022, but I don't think they've probably changed that much. We haven't added that many settings, but there are a lot of different kinds of things that you can do in CellProfiler. So there are things where you can name things, you can put in floats, you can make things that have different color maps. And so we have to support a lot of different ways of doing things. But also, when I tell you that CellProfiler has 930 different settings across 95 modules, you can see how the ability to be powerful ends up being potentially something for our users that is a little bit overwhelming. But the exciting thing about CellProfiler is that it has stayed relevant and is sort of continuing to stay relevant over the last, again, the original version was made in 2003. I'll give more of a history in just a minute. And I think there's a very good reason for that. I think in general, the part of the reason that CellProfiler has been so successful over the years has been that from the very beginning, from Anne and Ray working together, CellProfiler has always had at least one software engineer, where the folks outlined in blue, working on the code base, as well as one person whose initial training is in biology. Hi, the folks in green, working on the code base together. And so it means that while our software follows, as many software best practices as we can, the way that things are structured is always tailored to sort of how biologists think about problems, what biologists want, how they tend to describe things, and that has sort of helped us stand the test of time. This is the current team, although my contributions are limited these days. We're excited that in the past month, we've welcomed a new engineer to the team, Suraj Pratak. We did not make him come and give a talk about his new job that he's been in for 4 weeks, because that seemed unkind. But I'm sure if we were doing this talk a year from now, you'd be hearing about all of the great things that he has done. For me, I've been a member of the team for 2016, but a fun fact that may be fun to only me, I happened to send an email on the day that I found CellProfiler, so I can trace my CellProfiler versary back to 15 years next week. So while I've only been working on the software for 9 years, I've been a user of it from the very beginning, and part of the way I got the job at the Bird is I was able to point out that in the CellProfiler forum, which was the precursor to the image.sc forum, I was in the top 50 posters already when I got here. So, which could have been a bad thing, I suppose, that I raised too many bug reports and things, but they let me in anyway. So also thank you to Nico Sturman for, me having a career. That's always exciting. To give you a brief, not so technical overview of CellProfiler, this was the oldest CellProfiler screenshot I could find. It's from a grant that Anne Carpenter submitted in February 2004 of the original MATLAB version of CellProfiler. You can see that it is already called CellProfiler by that point. And Anne was also a cell biologist by training who had a problem. She wanted to do some high content screens, and there was no way to do that without her having to write some code. So Anne, being the lovely public-minded person that she is, she said, well, if I have to write the code for me, I'm going to write code that everybody can use. And so in this original version of CellProfiler, you can have up to 8 modules total that you load in a particular module. And so at that point, there were some segmentation modules and some measurement modules. Obviously, we've now grown a bit beyond that. But you can see the sort of basic bones of what we have in CellProfiler today already present in this very early version, which she had accomplished within her first few months as a postdoc because she's Anne Carpenter. And the software has generally stayed on the same block. We at the Broad Institute are directly next door to the Whitehead Institute. So Anne started it as a postdoc and got a paper out of it in 2006, moved it next door to the Broad with her when she came over in 2007. And since that move in 2007, we've had 3 major releases of CellProfiler. CellProfiler 2 was the first version that was in Python rather than MATLAB. CellProfiler 3 in 2017 was the first version to support 3D. And then in late 2020, we were all stuck home finishing our code. We released CellProfiler 4, which was the first version that was written in Python 3. And then when I started my lab in 2021, CellProfiler moved down the hall with me, and literally 2 doors down. And that is, I did not put on here, but is also one of the first hires I had after doing that was Nodar to come work on CellProfiler with us. This is for the software engineers in the room who might be interested in sort of how some of these things developed. And sort of sets up some of the things we're going to talk about later. When CellProfiler started in that should have said 2003, it began in MATLAB, and modules are imported into a pipeline. So modules are a thing that are sort of separate, which is part of the reason that why we think many of the module code is written the way it is. And was originally GPL licensed. So there originally was a path for commercialization of CellProfiler in theory, though that path has never really been followed. In 2008, they started prototyping that probably MATLAB wasn't the solution here, especially because About 25% of people at the time said they wanted to be able to modify the source code, and you couldn't do that without having a MATLAB license, which they felt was too high of a fraction of the user base, even if 75% of people are using it out of the box. Which led to the first official Python release, which at the time, CellProfiler then, because it is using bioformats, which is used in ImageJ under the hood, to do image loading, CellProfiler actually packaged ImageJ inside it. So it came with a copy of ImageJ inside CellProfiler. In 2014, we had the first release with CellProfiler's current input module system, moved from SVN to Git, and added a lot more bridging. CellProfilers are always really cared about interoperability. So it added Amero support, as well as, if for the Windows version, it also then brought its own copy of Elastic. So now CellProfilers bring its own copy of ImageJ and its own copy of Elastic. That didn't last very long. Unfortunately, that was really hard to support. So when 2.2.0 came out in 2016, not only were Amero, ImageJ, and Elastic jettisoned from the CellProfiler build, it actually jettisoned the entire Java packaging that goes into CellProfiler that is required for bioformats loading. So as of 2016, you had to bring your own Java. So you had to install two things rather than one thing. Also, at that point, CellProfiler moved to a BSD style license, which sort of officially closed off that commercialization path, which hadn't taken in the first 10 plus years, was probably not going to get taken. When I joined in 2016, the team was gearing up hard at work to get out CellProfiler 3.0.0, the first version which supported 3D and had some major UI updates. Those of you who are old school users of CellProfiler will remember the strange forest green color that has now been replaced with the gray. And we realized after a couple of years that having people install two packages instead of one package, even though it made our lives simpler as developers, was not going to work. So we started putting Java back in. As well as we started trying to make sure that CellProfiler could be more future-proofed, because as much as we hope people upgrade their CellProfiler, people don't. Biologists do not upgrade their software, ever. We still have seen papers in the last year directing people to use CellProfiler 2.1, which is not even on this slide anymore. And so how could we make CellProfiler future-proof when people simply do not want to upgrade? And so containerization was a major way we felt we could support that. We then started breaking CellProfiler into bits in 2019 in preparation and as part of moving to Python 3, since Python 2 was hitting end of life at that point. We split out all of the core functionality, everything that is under the hood, and made that a separate pip installable package and even entirely separate repository from the actual CellProfiler modules and documentation themselves. That let us get CellProfiler 4 out the door in 2020. And in 2021, we had two major versions come out, or minor versions come out, excuse me, including resumption of ImageJ support with run ImageJ macro. In 2022, we started moving some of the mathematical stuff out of the modules into what we call CellProfiler library, which I can show you in a minute. CellProfiler, and in 2023, all of this, okay, we've split things out, we realized had gone too far, and now we're made sub-packages into a CellProfiler monorepo. So a lot of the history of CellProfiler, as you'll see, is things where we make a decision and then realize parts of that decision were good and parts not so good. We also had the first time that we're starting to use Docker under the hood to bring in things like CellPose and Stardust and other deep learning things that by that point were very, very popular. And it took us till 2024. It took us 8 years without Elastic, but we finally brought Elastic back via CellProfiler's plugin system in last year. So what's it like working on and using CellProfiler? You'll probably hear me say bad things about CellProfiler in the rest of this talk, which is a thing you say about things that you love but wish could be better. Here is a list of things that Nodar and I came up with for things that we do love about CellProfiler, and I have my CellProfiler at the ready to sort of show some of them. One of the things that's great about CellProfiler is it is complex enough to solve most problems, but it is also simple enough to reach many users. And part of the reason for that is the documentation and the in-app help. So here's my copy of CellProfiler. And if I'm ever not sure what a module is doing, I can just click on the question mark button, the most important button, and we find out quite a lot about what are in this case, the measurements that CellProfiler is making. And if I want to know more about, for example, what a particular setting does in a very complicated module like CellProfiler's object finding modules, I can go in and I can even get some recommendations about when a particular mode is good or not so good. Also, the ability to bring in plugins, which I sort of alluded to briefly. But yeah, if CellProfiler isn't doing a good job, live demo time. Let's see how this goes. I can say, I'm not sure CellProfiler is doing a super good job here. I would like to use my local copy of Elastic to pull up a thing. I don't have the right pipeline loaded to do this. That is not the pipeline for that, Beth. So if I put in a different pipeline, and there's nothing particularly special about Elastic in the sense of many things can be connected to CellProfiler via plugins. This is just one of our particular favorites. So all I have to do is tell CellProfiler where my Elastic integration is. Uh-oh. I had Elastic on my computer. I hope when oh, there it is. I upgraded my OS on Monday, so this is a dangerous thing to be doing the same week you upgrade your OS. I'm now running CellProfiler. This should have been downloaded from the CellProfiler website. As of 8 years ago, it's not shipping Elastic anymore, and it never did for Mac, but hopefully in my live demo. We're now starting up my computer's copy of Elastic, so all you need is the two pieces of software co-installed in the same machine. And we're using Python's ability to call out to different tools via subprocess to actually pull this off. Hooray! This was extremely overkill, but I've now identified some nucleoli using Elastic, but I could have run it via Elastic in a container as well.
Yeah, so kind of continuing down that path, a lot of the niceties we get from documentation, first of all, should be mentioned, is that it's programmatic. So the actual documentation that's written in those, whenever you press a question mark in the GUI and some documentation shows up, it's written as comments in the code. So the code and the actual documentation live together, and the documentation, like the actual PDF that you can get, from the website is also generated from that. So whenever I, as a software engineer, am modifying a module, tinkering with the settings, adding new settings, I can write in the documentation there, or even check the documentation to even remind myself what this particular setting I'm modifying is supposed to be doing. So from a development standpoint, that's a very nice thing to not have to separate those two out. The plugin system architecturally is possible to do easily because we have modularized the modules. So each individual CellProfiler module is relatively isolated to the point where you can write a .py file and extend the base module class and add in a few mandatory function methods on that class. And as long as you haven't made some syntax error, and as long as you're not importing something that doesn't actually exist on your computer, when you launch CellProfiler and point it at your plugins directory, it will just register as a plugin. There's no special API that you need to access. There's no plugin registry that you need to register your plugin to. It's sort of just something you can put in a folder, and CellProfiler will pick it up. And when you're writing a plugin, or when you're writing a standard CellProfiler module, it comes with that base class I mentioned, comes with a few standard methods that you have to use, and then a collection of standard methods that are optional to use. And those form a series of lifecycle methods. So CellProfiler is a pipeline of tools that run consecutively in order. And before that pipeline runs, during that pipeline running, after that pipeline runs, the module's lifecycle methods are calling. So it's like pre-run. So before that module runs in the pipeline, the run function, which is actually the core logic, the display function, which is like what will CellProfiler display, if anything, after the module completes and it has produced objects out. So writing a plugin or writing a module or refactoring an existing module is all tied around this lifecycle, which makes it very easy to kind of reason about and to kind of order things depending on if you need to do something before it runs or during the run or after. Although there's many things I could say about the GUI framework we use, WX widgets, that isn't on the positive side. One positive thing about it is that it taps into your OS's native GUI. So when we write our GUI code on a Mac, or when we write our GUI code and you run it on a Mac, it taps into the Mac's native widget system. So it looks like a native Macintosh app. And that same code, without any modification, when you run it on Windows, it looks like a Windows app. So again, there's many things about the GUI system we wish were different, but that is one very nice thing to have, is that because we're running Python code, which is cross-platform, because there's a Python interpreter for every platform, and because we're writing it in a GUI system that is by design cross-platform natively, you get this nice feature of there's very little in our code that says if Windows do this, if Mac do that. It's more or less identical across platforms with some very few special cases. I think there may be like one or two conditions around how we handle Java and stuff like that. And then the last thing I'll mention on the GUI side is that over time we've developed, and this is before my time, so it has been developed, this large library of little widgets written for each possible setting you could think of. So if you're writing a CellProfiler plugin or a new module or anything, and you need to support a setting of some kind, like a dropdown, a button, or something more advanced like get CellProfiler objects, those are already built. All you have to do is just tap into the library and import it into the code. It is extremely rare. I mean, it's possible, but very rare that you have a setting that's so novel that it hasn't already been written. So that's quite nice from a development standpoint.
As with everything, unfortunately, again, there are many things we love about CellProfiler. There are some things that we love less, but we can probably also fix eventually. Oh no. So I mentioned the module's math code is interspersed with the module's logic and interface code, and Nodar just actually pointed to some reasons why that's a good thing. But it does mean that as we try to make any changes to how module's math code works, often you have something that is a couple hundred lines of Python code where the run function has one actual line of math. And that can make trying to figure out what a particular CellProfiler module does, especially if you're somebody who started with CellProfiler and is now trying to move to other parts of other sort of coding, maybe writing your own Jupyter notebooks, makes it very hard to figure out, okay, where is the one line? Where is the one line that I need? There's also not currently, though we have plans, little ability to distinguish between what is possible versus what is recommended. So what do I mean by that? So let me return to this pipeline simply because it is open. So here is my existing thing. I need to move all of your lovely faces. Where I am identifying nucleoli objects just from the image without putting them through Elastic. You can see that this is doing a pretty good job overall. And part of the reason that this is doing a pretty good job is we're using an automatic thresholding method, minimum cross entropy, that is pretty nice and robust. So if we look at the histogram here, this is most of our image is background, but it is doing a nice job of ignoring those background pixels. And if we sort of zoom in here, it is doing a nice job of figuring out the background peak versus the foreground peak and coming up with a line which is 3 zeros and a 5, so about here, saying all of these peaks are background, all of these peaks are foreground. Now, because thresholding methods don't always do everything perfectly, we have some things in CellProfiler you can do to modify it that are often extremely useful. So you can adjust the threshold if you find that CellProfiler is typically a little bit too high or a little bit too low. You can also set a minimum and a maximum. But so while I can set this minimum to 0.001, which would be a perfectly reasonable setting in other cases, CellProfiler is not going to help me figure out, unless I go through it myself, that for this image, for these things, that's a terrible setting. And even in the case where we have something that is a less reasonable thing to do, so I could take the threshold that CellProfiler is calculating and correct it by, say, multiplying it times 100. You can guess how this is going to go. This is going to go badly because we have a beautiful automatic thresholding method that somebody took the time to actually write, and we're saying, yeah, take that and multiply it times 100. Generally, that does not go well, but a user who hasn't taken the time to learn what every single setting button does has no way to know that that is a possible thing to do, but maybe not a very sensible thing to do. So there's some knowledge of image analysis that's required in using CellProfiler well. The data export functionalities are unfortunately confusing and outdated. If you want to export, you can either export your measurements to a spreadsheet using export to spreadsheet or to an SQLite database or MySQL database versus export to database. That's fine. But if you want to export only some of your measurements, say, you know, you've used measure object size and shape, which makes 20 measurements, you only care about 3, you can do that in export to spreadsheet. You cannot do that in export to database. Why? Historical. The other thing is that 3D image reading, or the other thing I wanted to point to specifically, 3D image reading is a pain for users. When we were initially trying to get 3D images into CellProfiler, which happened, 15 years into its history almost, in order to get around CellProfiler's complicated image loading system, which I will talk about in a minute, it was decided to just support a particular style of image, which was a 3D TIFF with a single channel. So if you have 20 Z-planes and 3 channels, you must have 3 20 plane images, no more, no less. And that's unfortunately not the way users use. And so there's lots of things that we could do to try to make that better.
For these last two items, just for the interest of time, I don't want to go into what I would like it to be, but some pain points we have is on the concurrency system and how measurements are handled internally. So these are all very in the depths of the code base, and not at all something that the user even notices unless it goes wrong, obviously. And for the most part, we have not noticed it going wrong too often. So it's sort of in a place that is working. Every once in a while, a bug comes up. If a bug comes up with regard to either the concurrency system or the way measurements are happening, it's rather tricky to actually diagnose and fix, just because it's hard to find out what's happening. And just very quickly, what I mean by the concurrency system is if you're running in the GUI, and you want all your computation to go faster, you can specify a number of workers and in the settings, and then when you launch a pipeline, if your computer has 4 CPU cores, you can set 4 workers or whatever matches your computer's capabilities, and then it will try to parallelize the work where possible. And so to do that concurrent processing, you have to have a system for managing the work done by those workers. And that system currently works, but the code is rather complex. I have the whole diagram trying to spec it out in the wiki, but in general, even though it works, it's very difficult to get it to work another way. If you want to extend it or modify it to do something it doesn't currently do, it takes a lot of thought and care to not break anything. And similarly with the way that we do measurements, there's nothing broken about it currently. It's just that we have written such a large amount of code to wrap a very custom use of HDF5 that if we wanted to do something very different, then it's a pretty painstaking rewrite to have to incur. So until we want to do that different thing, we try to delay that rewrite. But again, these pieces are relatively isolated in the code base, and so it is something that we can get to, and that's why we have it under the eventually category. It's just a matter of like where it comes in our priority list.
Yeah. Major pain points that people complain about CellProfiler that unfortunately aren't going anywhere, and we'll explain why in a minute. CellProfiler has no loops, ifs, or elses. CellProfiler is going to run in a line, and that is what CellProfiler is going to do. You can't say if this, then that. We need to handle proprietary formats, which isn't necessarily CellProfiler's fault, but it means that even though we are a Python program, we do need to bring Java somehow, whether it's Java we maintain or Java other people maintain. And doing the bookkeeping of image ingestion is hard. And again, this isn't necessarily a problem with CellProfiler. It's a problem that people have data stored in many different ways. Some people have a proprietary file that has a whole plate of data in one file, and some people have thousands of files that all support a single actual logical experiment. There's no way to know without doing some bookkeeping. And this is just to show you how much we try to teach people about how to do that bookkeeping. And we've in fact made whole video tutorials and blog posts about how we can have people try to get their data into CellProfiler, but if you have to have a tutorial for it, it's probably too hard. In the last few minutes here, just some lessons we've learned about legacy user-friendly software. Some of them we're still learning. Interoperability matters, but it is hard. In a much smaller tool world, we still couldn't easily maintain consistent integrations with a small number of our favorite tools. Keeping up with making sure that CellProfiler and ImageJ update hand in hand didn't work out for either team. Same thing with Elastic. Keeping those things up to date at the same time didn't work out for either team. There's no longer two pieces of software now to integrate. There's now many, many amazing pieces of software that we would love to partner with, but the ways we were doing things weren't working. And so we need to think of new ways to integrate stuff that are more maintainable than what we were doing. Some of that I mentioned briefly, we can do via containers. We've created a tool called bilayers that in the interest of time, I will not complete this demo, even though it's only a minute long, but it is a thing we are using so that containerized tools, we are now finalizing the code that will then allow you to programmatically make a CellProfiler plugin for your favorite deep learning tool. So watch this space. And we also have some ideas around how we can talk to other tools via ports. And the way that we see going forward for ourselves and as a community is simply that, the more we can make the code modular, the more we can make CellProfiler not a monolith, but to make things so that everybody can contribute and the whole community can be working on things that support multiple other tools, the better we'll be. Scikit-image and CellProfiler have had a symbiotic relationship for as long as those two things have existed, and we're excited that tools that other people have made, like SwiJava and BioIO, are taking over functionalities that CellProfiler once served for the community, and CellProfiler built some custom things for itself that other people in the community used, but somebody built something better, and that's great. And the more the parts of CellProfiler are sort of atomic, the more easily we can do that. It's part of why we're doing CellProfiler library, because people kept saying, when is the CellProfiler Napari plugin coming? We're like, oh, it can't for technical reasons, but yeah, let's figure out a way to do that. And being able to do CellProfiler library allows us to give back to that same community that is constantly giving back to us. Unfortunately, sometimes the right decision is not the right decision for your user base or even for yourselves. Two sort of examples that we've alluded to already. Having to bring your own JDK isn't that hard. You install two things instead of one thing. But it meant the first 30 minutes of every CellProfiler tutorial was helping people install the JDK. And if it was happening in a tutorial, Lord knows it was happening to people trying to install at home. So even though it didn't seem like a huge burden, it was. Likewise with CellProfiler core being in its own repository, in theory, you just had to track two repositories and keep two repositories up to date so that if we made changes to the underlying analysis system, you could, bring them into the main CellProfiler program. In practice, it was a huge pain in the butt. And so even though it was a good idea for many reasons, because we want things to be modular, we ended up keeping them different packages, but bringing them back to the same repo. Legacy software means living with some things, some technical details from an earlier time. Tools that can loop and if else exist now. And there's a lot of functionality for doing workflow graphs and things in Python that we could take advantage of if we were writing CellProfiler from scratch today. But CellProfiler at this point is designed to run a pipeline linearly, and to change it so it doesn't do that would basically mean making a whole new tool. So we have to live with the choices that past us made. One example of that when Nodar and I were chatting yesterday about what we would talk about here is that CellProfiler did not in 2008 anticipate that gradual typing would become a thing in Python 10 years later, because the crystal ball, I guess, was in the shop. So even though it would be great if CellProfiler was typed and we're moving to do some of that in CellProfiler library, it's not a thing that probably the whole code base can ever take on. But when in doubt, we listen to our user base and we try to figure out what they need from us. If the CellProfiler inputs are too hard, what can we do about that? If there isn't off-the-shelf deep learning, can we stick plugins in containers? If we can't handle large images because it's no longer 256 by 256 world, can we work on that? And Nodar will show you a quick demo. But if you want to know more about weigh in on what we're planning, ask us questions, tell us things that are wrong and hard in our GitHub discussions and on the image.sc forum. Those are the ways we prioritize the changes that we're going to make, is what is hard for our user base, because if it's hard for them, it's not what CellProfiler is meant to be doing. And so if there are changes you want to see in CellProfiler and you are capable of making the changes, please do. But if you just want to report that there are changes that need to be made, you can do that too.
Okay, I just want to, as Beth said, really quickly demo one of the things we've been working on in CellProfiler, which is large image support. This is a project that over time sort of realized that it's going to be multiple little sub-projects, all kind of stacked up on top of each other. So the first portion of supporting large images in CellProfiler is just getting the image viewer to be able to view them. And really quick, what do I mean by large images? So here's an example of a public large image, which I'll be demoing. And it's 75 gigabytes. Plenty of people have enough RAM in their on their system to hold 75 gigabytes, but a lot of people don't. So we want to be able to view the entirety of this image without loading it into memory. And that's what we mean by large image. It's some bigger than memory image. And there are various other definitions you can use for large image, but that's one level that we've defined. So the same image from Bioimage Archive I've loaded here. And the only thing special that's been added is we have this process as tiled to live alongside our process as 3D. And normally, if you were to outside of this branch I have, if you were to double click on this image, it will try to load the entire thing into memory and give it to matplotlib to view. But because it's 75 gigs, that would take a long time, if not just blow up my memory. Instead, you see the entirety of the image come up because this is actually a tiled and pyramidal image. So it's giving you a low resolution version of the image. So the pyramid allows you to have multiple resolutions. And this is the lowest resolution. So this particular image being displayed is not 75 gigs. It's something much smaller than that. But if you want to then descend the pyramid hierarchy and go to a higher resolution, you can do that by just navigating via this little widget in the top right. So now we're at like a slightly higher resolution, double the resolution. And there's now two tiles in this resolution. You can navigate the tiles this way. And again, you want to kind of go into a lower resolution, higher resolution at a lower level in the pyramid. You can do that and navigate the tiles. And then you can do that consecutively all the way down to the highest resolution, which has hundreds and hundreds of tiles in it. And so none of these tiles all of these tiles are not loaded all at once. They're sitting on the hard drive. But when you actually navigate to a tile or a level in the pyramid, it's loaded only when you need it and only the chunk that is needed at that time. And so that's the large image viewing, which needs a few fine-tuning things, but that's basically it. And then further downstream from that, what the project becomes is getting all of the modules to recognize that images can be tiled and how to process those tiles individually, which is something that has been worked on by many people in bioimage analysis. There's like repositories in GitHub dedicated to it. So it's not the hard part of like figuring out from scratch what does tiled image processing even mean. This has been a problem that's worked on. It's what it means in the context of CellProfiler and how it integrates with the legacy code base that we're dealing with. We can't just say all of a sudden to CellProfiler, hey, tiles exist. We have to like bake that knowledge into the code in multiple places without breaking any of the existing functionality. So it's more of a challenge of like, how do we refactor this without having to rewrite the whole tool? How do we bake in this knowledge into CellProfiler in a way that allows you to take advantage of some of the existing image processing tools like Dask that exist, but plays nicely with the CellProfiler code base as it is now.
So excited about that. We've time for a couple of questions, I think. No.
Hi. Well, thank you for your wonderful talk. Just one question from AC Coxoy. He says, up to how many channels can CellProfiler tolerate for fluorescence stained images? And if can it read QPT files, and can it batch analyze these kind of images?
Yeah, CellProfiler uses bioformats under the hood. It's why it requires Java. And so in theory, anything bioformats can read, we can read. Whether it can do it gracefully is something else, which is a big part of what Nodar is working on right now. In theory, there is no upper limit on channels. For doing things like multi-cyclic experiments, I think my personal record is something like 50-something channels in there, but I know, for example, the Bode-Miller group do some things with image mass cytometry where they put in even more channels than that.
Thank you very much.
There's another question from our own Rocco that asks, is the run elastic special case of integration, or can the same plugin template be adapted to any AI pair, meaning data and trained model? And what are the requirements for other software to be pluggable as run elastic?
I'm so glad you asked, Rocco. If you visit plugins.cellprofiler.org, you can learn all about it. In theory, to be compatible with CellProfiler, another tool has to be just sort of runnable from the command line. So in the case of Elastic, I showed you that we offer two options, one of which is to use Elastic's own built-in thing where you can run it from the command line on batches of stuff, and that's also what we use for ImageJ. Or if there's a version of it that lives in a container that is servable from a Docker container, and we've not yet pulled, but we did sort of investigate literally last week that Podman is working just as well as Docker, and we expect Singularity will too. So if you like containers but not Docker specifically, there are other options. But we do provide templates for plugins, which you are, and we have a list of supported plugins on the plugins.cellprofiler.org website. And with our new bilayers project, we hope that we will be able to increase the number of deep learning tools that are available in CellProfiler very quickly at that point, because rather than making each plugin sort of bespoke by hand, we can make them automatically.
Yep, thank you very much. If you have other questions, you can put them in the question and answer box. I want to thank also Isabel Fernon, Esteban Milleta, and Paula Llanos for connecting and helping with the question and answer.
Yeah, it seems that we don't have any more questions, so I will make one. Is there a date for the release of the new version of CellProfiler?
I could answer that because it depends on the velocity of Suraj and I. But the general answer is there's some features that we want to have in CellProfiler 5 that warrant it moving all the way from a major version update from 4 to 5. One is large image support, and like I said, that comes in layers of support, and so maybe not every possible kind of dream we have with regards to large image, like we might not support stitching as gracefully as we'd like, or something along those lines. But we want to have large image support generally. We want to finish the library refactor so that you can use CellProfiler, its logic to produce features, to produce measurements that are consistent with the way that CellProfiler via the GUI produces those measurements, but accessible programmatically in a notebook or via another tool without you having to install CellProfiler, which is like more than, I think, 2 gigs at this point. So you just install like the relatively small CellProfiler library and can use it that way. And then we would like to address the export system that, as Beth mentioned, is kind of outdated at this point. And then we have a few other existing open issues on GitHub that we'd like to throw in there, and some mess to clean up afterwards. But those are really the main kind of things we'd like users to be able to use when 5 comes out. So when can it occur? So one sub-project of large image is done-ish, and I sort of have a path forward for working on the other ones. Library, Siraj is going to dedicate most of his time to working on that, and I'll be working alongside him on that. And so over the next year, we plan on focusing all of our time on the 2 main features we want to have in CellProfiler 5. As for an exact date, I refuse to give it, because it's programming and things kind of come up that are very unexpected. There might be 90% of the library might be easy, and then the last 10% might be extremely difficult that requires some large code rewrite that is unexpected. And it's because it's exceptional that it's hard to get an exact date. But we'd like to make a large amount of the headway over the next year.
All right. Thank you very much again, Beth, Cimini, Nodar, Gogoberidze, for the nice seminar. And if there are no other questions, I just want to say hello, everyone, and thank you for joining.
Thank you so much for having us.
Thank you.
See you all on the forum.
Bye. Thank you.
Everyone. Bye.
Thank you.